All right, well, thank you everybody for attending. We're going to talk a little bit about data science, and before we get to that, I need to start with a kind of a tricky question. So can you please raise your hand if you know what Jupyter notebooks are? Okay, so for people following online, most people know it. Can you keep your hand raised if you like Jupyter notebooks? Okay, yeah, lots of hands dropped, which is about the answer that I expected, so my anxiety is much lower now. So, okay, I got it. Lots of people don't like Jupyter notebooks, but it turns out that many other people do like them. So, for example, that's why there's this 2018 article in the Nature journal about why Jupyter is data scientists' computational notebook of choice. Or for example, the fact that in the Python survey of 2022, there's this suspicious other category in the IDE, the primary IDE question, that probably hints that there's something that data scientists are using that is not VS Code, it's not PyCharm, and it's not Vim. So I will take an educated guess and say that it's Jupyter probably. And in the following question, which is, what is your most widely used secondary IDE? You see that Jupyter Notebook comes in second, and well, there's some overlap between Notebook and Jupyter Lab, right? But if you add these two percentages, it's very clear that it's the most widely used secondary IDE. So much so that only on GitHub there are more than 10 million public notebooks at this point. There's some research that the JetBrains people did, and they hinted that, you know, in 2018, so 2 years before this article, there were like 1 million public Jupyter notebooks, and then in 2020 there were 10 million almost. So can you imagine 3 years later what has happened? So okay, 10 million public notebooks. Imagine the amount of private notebooks that exist. But then half of the people in this room do not like Jupyter notebooks. How can so many people be so misguided? And it turns out it's a little bit more difficult, right? So according to some models in any machine learning operations process, or MLOps for short, there's an experimentation phase. So you come up with a use case for machine learning, and then you start iterating and so on. And then there's a production phase in which, again, it's an iterative process because you have to update your code, then make sure that it's running correctly, and so on. And what happens is that the people that like Jupyter notebooks are often on the left-hand side. The people that lower their hand are on the right-hand side. And in the middle of that, it's what I call the chasm. Okay? So the point is, how can we make sure that the left-hand side and the right-hand side talk together when the people that use notebooks don't really understand the methods and the processes of the people on the right-hand side, and the people that work in the production of these systems don't really like notebooks at all. So before going to that, I introduce myself very briefly. So my name is Juan Luis. I'm originally an aerospace engineer, and then I taught myself Python because I needed it for solving some equations at university, and here I am. And at the moment, I'm product manager for Kedro, which is an open source Python library for data pipelines at Quantum Black, which is part of McKinsey and Company. I'm currently the organizer of the PyData Madrid monthly meetups, and previously I've been very involved in the Python community in Spain in general. So I co-founded Python Spain nonprofit, and I organized the first 7 editions of PyCon there. I've been contributing code for the SciPy and the PyData ecosystems for almost 10 years, and I've been working in that chasm that I mentioned before for about as long. So I'm obsessed with bringing scientists, whether data scientists or science scientists, and engineers together. So to answer the question of how we can cross this chasm, I had to go back in time just a little bit, you know. Bear in mind that Jupyter Notebook, with its current name, was introduced in 2014 by Colombian programmer Fernando Perez. At the beginning, the logo resembled these annotations by Galileo in his notebook in the 16th century when he was observing the moons of Jupiter. And that was about the time that notebooks started to take off. For example, there was this cover in Nature, and you can see there on the bottom that there was an article devoted to IPython notebooks. And that year also, O'Reilly introduced notebooks as a way to author technical books, which was kind of impressive. And that same day, I don't know if this was coincidence or not, GitHub also added support for Jupyter notebooks to their interface. So this all happened in 2015, and at that time I was giving a very well attended talk, I must say, at PyCon Sweden, so this was already 8 years ago, about IPython and how it was enabling the new generation of open science and so on. And I talked about Jupyter, and I, of course, picked an enemy, and this presentation contained this slide over here. So you might imagine, what am I talking about, right? It was easy to pick Excel as an enemy, because we had so many recent disasters that had been happening recently. For example, there was this not so famous article by the economists Carmen Reinhardt and Bernard Rogoff that proposed basically that the more debt that the countries were taking, it was in the long run really bad for the economy. And this was like the article that justified the budget cuts in Europe at the beginning of the past decade. And it turns out that the spreadsheet had some dubious assumptions and some arithmetic errors, so the conclusions were exactly the opposite of what the paper was intended to show. And this was very famous in the open science community back then. But there was no shortage of problems caused by Excel. For example, in 2020, there was this article by The Verge that said that scientists have to rename human genes because Excel is constantly turning them into dates. And this is a very annoying behavior that apparently couldn't be turned off back then, to the point that, as the subtitle says, it's easier to rewrite genetics than update Excel. And the same year, in 2020, there was this super fun thing that happened because in the UK, they were adding COVID cases along columns instead of along the rows. And so at some point, Excel ran out of columns, and there was some period of time that they were undercounting COVID cases by 16,000, So with all these things, how could I not possibly pick Excel as an enemy, right? Or maybe we're missing the point. Why fixate so much on a specific tool, right? Because, if you think about it for a moment, bad things can happen no matter what tool you use or what programming language you use. So to get to that question, I need to go back in time a little bit more just to present you the biggest hater of the history of computing, Excel Dijkstra. So this guy was really famous in the 70s because he won the Turing Award in 1972, so he really knew what he was doing, and he had tremendous contributions to the world of computing. And he was also known for having very harsh opinions about virtually everything, really. So let's see what Dijkstra had to say about Fortran programming language back then. I'm going to read out loud. The sooner we can forget that Fortran has ever existed, the better, for as a vehicle of thought, it is no longer adequate. It wastes our brain power, it is too risky, and therefore too expensive to use. Fortran's tragic fate has been its wide acceptance, mentally chaining thousands and thousands of programmers to our past mistakes. Wow. There were some harsh words by Dijkstra. I don't want to think how the Fortran community took this criticism back then. But, the point here is that Dijkstra, maybe it's putting too much emphasis on the tool, and he criticized virtually every language that existed back then, so I'm not going to follow all of that. But the idea behind this implicitly is the idea of linguistic determinism. So from the Wikipedia definition, linguistic determinism is a theory that says that the language that you learn or the language that you use limits and restricts your ability to understand the world in some sense. So this is now generally agreed to be false by modern linguists. However, there's a weak principle that is called these days linguistic relativity, which means that the language can affect somehow your perception of the world, So it doesn't cripple your mind forever, as Dijkstra seemed to think about Fortran for programmers back then, but maybe it has some influence. Or better put, you can write Fortran in any language. This is the Jeff Atwood article where I took all this information from. It's really old, it's from 2005, but I think it's as important as ever today. So, okay, if the language cannot cripple your mind in terms of how do you understand computing, but it does affect a few things, then what do we do? Well, there are some things that we can fix. For example, some of the other very famous contributions of Dijkstra was this article called "Go-to statement considered harmful," that apart from giving way to probably the biggest cliche of computing today, because now everybody repeats this considered harmful thing, it had a very important lesson, and it was that we have to go towards structured computing somehow. So the presence of the go-to statement was impeding our ability to progress and write more complex software. In fact, there's this article by Nathan Smith, which is a very influential person in the Python community, that came up with the concept of structured concurrency, and he has a very nice description of these issues. So, for example, if you see the with construction in Python, which is what we call a context manager, everything that happens inside that context manager assumes that the file is open, and everything that happens outside assumes that the file is closed. And if you think about it, this is really cool because you don't need to manually open and close the file. But if Python had a go-to statement, you could never do this, because if your program execution flow can jump at any point in your program to somewhere where the file is open or closed, then basically you cannot make any assumptions and you cannot make any progress. So it's an example of a feature that the moment it exists, it limits your ability to grow. Okay, so with this in mind, back to notebooks. What does this teach us about the current situation, right? And the fact that many people dislike notebooks. Well, people dislike notebooks for very good reasons. For example, there's this research that I found in the Greg Wilson blog that said that basically 90% of the public notebooks that exist don't have any way of installing the dependencies and so on. So you basically download a notebook, and then you don't know what software were they using to do the analysis. And even if they specify the dependencies, the versions are no longer up to date, so the code still doesn't run. And even if they specify the dependencies in the right way, the code, for whatever reason, doesn't run top to bottom. So if you go and read the article, you will see that they analyzed 100,000 notebooks, and only 725 were fully working. So that is less than 1%. And there's no wonder that people have had bad experiences with notebooks. And also, on the other hand, there's this super amazing talk by Joel Grus called "I Don't Like Notebooks." This was from JupyterCon in 2018, and I highly recommend you to watch it because it has so many amusing examples of things that happen when you're working with notebooks. I don't agree with all the solutions that he proposes, but definitely the problems that he was exposing were very real at the time. And for example, there's this typical thing if you've worked with notebooks where you start accumulating untitled notebooks over and over again, and very quickly you start losing track of everything that you have. Okay, so there are some specific problems, and not everybody likes notebooks, but also it's a very useful tool. So I'm going to conclude this presentation and give some time for Q&A by stating a couple of things that I think we should not do, and two more things that I think we could be doing a little bit more. So the first one is that we should stop telling people that the tools are bad. You know, there's lots of discourse online about how notebooks are bad, and by using them, you're a bad scientist or a bad data scientist and whatnot. And I don't think it's taking us anywhere, because, if Fortran resisted the criticism of Extra in the 70s, and it's still very much alive 70 years later, we can assume that Jupyter notebooks are going to continue existing for a very long time. So we better stop telling people that their tools are bad, or that they are bad because of the tools they use. Bonus points if you actually try to be helpful when people express their problems and the technical issues with any sort of computational tools. And second, I think we should stop telling people that they must be the masters of everything. Our profession as data scientists or data engineers or machine learning engineers is already difficult enough. Like, if you want to be a good software engineer, that's really hard. If you want to have deep domain expertise, that takes years to accumulate. And if you want to have good mathematical and statistical skills, well, I don't need to tell you that you need to study a couple of textbooks, right? And if we try to pretend that people are doing the data science part, so the exploration part, can also become excellent software engineers and use fantastic tools and dump everything to production directly, then I have some bad news. We already had that some years ago. It was called the Drew Conway's Venn diagram of data science, and it didn't work because we tried to stay on the data science part, but in the end we ended up in the danger zone part, or in the traditional research part. So that didn't work 10 years ago. The industry has matured, and now we have different roles that do different things, and so I think we should continue that trend. So what to do instead? Well, first of all, let's fix the problems that are worth fixing. And there's actual progress being made in all of these tools. For example, Jupyter now doesn't automatically save everything as untitled 1, 2, and 3. The first time that you save a notebook, it prompts you to choose a name. So this is a very good UX pattern, in my opinion. And it's very recent, I think, from the last version or so. But at least one of the problems that was exposed in Joel Gru's talk is already gone. Another one is this thing that notebooks have of the implicit state. That sometimes you have cells out of order and the execution is a little bit difficult to understand. So there are kernels now, like IPyFlow, that I'm demonstrating here, that if you affect one of the cells, there's a visual indicator that is going to appear in a moment, that you also will need to change some of the other cells. So you see, I changed that cell, and now Jupyter is telling me that I need to execute the other ones because they are out of date. And this is a very simple way of, addressing that problem. And there's even a method to do this automatically. So all the cells that are affected by a change are going to be executed. And well, Microsoft has fixed their automatic data conversion thing. So now you can actually disable it, and genomics will not need to rename the genes anymore. So thank you, Microsoft. It only took a few years, but we were finally here. And the second thing is that I think we should meet the users where they are. Our data scientists pretty much love notebooks because it enables them to do exploration in a very quick manner and so on. So why not meet them where they are? For example, when Microsoft announced this year that they were adding support for Python in Excel, I know like half of you are thinking this is a massive headache, and the other half of you are thinking this is awesome. I don't know what to tell you, to be honest. I think it's going to have pros and cons, as everything, but I think it's awesome that instead of writing like arcane macros on VBA or naming cells like A2, B5 and things like that, you can write actual code and a human can read. And I think this is a net improvement over what we had before. On the other hand, even Snowflake, the data warehousing company that is competing with Databricks, they just added Snowflake notebooks now. So before they were like a database, a columnar database for large amounts of data. And now they realize that to become a full stack data platform, so to speak, they need to add notebooks as well. So everybody is biting that bullet, so to speak. And it's what we're doing in Kedro as well. So Kedro is an open source data science framework. And for many years, the messaging has been like, don't use notebooks, use Kedro instead, right? And in the past few months, we've tried to evolve that messaging. And recently, we added an article to our blog that explains how you can use Kedro from the notebook. So, for example, you can define your data sets in a YAML file like this that specify where exactly your data lives and what kind of library you're going to use to read it. And then from the notebook itself, you should be able to load this data catalog thing from the YAML file. And then your notebook code doesn't care about if your file is a CSV file, if it's on disk, if it's on an S3 bucket, or whatever. The code becomes completely agnostic, so the data scientists can do their job and analyze things, but you don't have to care about hard coding, relative paths, or absolute paths, or things like that. So in any case, software engineers and data scientists, we need to talk to each other, and it looks like it's difficult if we don't move past the differences in tooling and processes that we use. But I'm confident that if we're empathetic to one another and we're kind to one another as well, we can continue building a working relationship and at some point cross the chasm. So thank you very much.
We still have about 3 minutes for questions. Anyone? No.
I have a very simple question, but it's a stupid one, so I hope you do not mind.
There are no stupid questions.
Well, I was not previously familiar with this product. I did look at IPython years ago, but I am not a Pythonista and I have never really used it. I cannot find a simple explanation of what is a notebook in this context.
So a notebook is like the idea of literate programming of Donald Knuth from the 70s. So a way to have in the same document code, explanations, images, video, and whatever. So it's a way to summarizing not only the computation itself, but also the results of the computation and any other media that you want to add. So it's like an evolution of the paper notebooks that scientists were using on a digital form.
Yeah. One question from my side. I use Python, so I have some experience with these tools. Do you believe like the default interface to using Python and learning it, which is in the terminal, black and white, is the scary part, which pushes new people, new learners who are more prone to making mistakes to go, oh, just install Jupyter and suddenly you can click buttons and you can click them in any order. Do you think that puts more responsibility on the Jupyter people to make it? So if you had to improve Jupyter, you would also keep in mind that a lot of people who are new to Python might be experiencing it through it. So do you believe that?
So, well, to the first part of your question, like, do I think that the terminal scares people? Absolutely, yes. Like, have you tried showing the terminal to a normal person lately? And you know what scares people the most? The fact that it's black. Because that reminds them of these hacker movies where the hacker is getting into the terminal and doing shady stuff, you know? If it were white, then people would just think, oh, this is just, you know, like a bad text editor maybe, or a confusing one. But, you know, there are lots of UI and UX decisions in the tools that we use that we take for granted that have like a very large impact, you know? So in that sense, the fact that Jupyter is friendlier in that sense, because like you can edit the text after typing it, right? Something that you cannot do in the terminal, or that it's white, so it's not sending you the message that you need to be a hacker to use it. I think it was a huge leap forward to democratize data analysis, data science, and so on. What other assumptions remain that are blockers for people to get into this? I don't know, but if we start questioning them, I think we can move forward.
All right, well, that's time. Thank you again to Juan Luis.